watching. I am back to do some more Leetcoding tonight. Took a break and did chess the other night, but I think tonight I'm going to get back to doing a few problems. So I'm going to pop chat up on my phone and then get started. And tonight I'm going to do a square root problem and then move on and do I guess you can probably all see them in the background there already, a same tree problem, which I haven't really looked at yet, but I think it's just comparing trees or doing a deep compare. And then I will go to if I get time, I'll jump to a sorted binary array or a sorted array to a binary search tree. And I do have one other pulled up, but I think 3 is probably going to more than fill up our time tonight. Plan to stream for about an hour, so without any further ado, let's dive in. So, and as always, if you're in chat and you want anything to be bigger or smaller, feel free to just ping me and let me know. So what I've got here is a square root of x. So given a non-negative integer x, compute and return the square root of x. Since the return type is an integer, the decimal digits are truncated and only the integer part of the result is returned. We're not using any built-in exponent function or operator such as power or x star star. The square root of x of 8 and the bit is truncated. Okay, so this is pretty interesting. I'm trying to think to how this problem without using, like it's setting built-in utilities of any kind. So the really obvious approach is just trial and error, brute force, where you start at well, no. So my first thought was to start at 2 and just start brute forcing it, multiply each subsequent number by itself and see if that gets you close. But I don't think that quite works because, like in this case, what we need is a decimal with the square root of 8, and we're not going to get that. So really, the square root of 8 is yeah, so that's interesting. And I should just trust Leetcode, but is that real? Because I guess 3 times 3 would be 9. So yeah, 2.82 something. So I'm trying to think if there's anything more clever I can do than just brute force walking back. And I suppose because there's really not an easy, or well, does that work? So what if I do 8 divided by, yeah, so I'm looking for a number where the original number divided by that number is very close to what I've got. So I think brute force may not be a terrible starting place. Let's just give that a shot. So the brute force algorithm is, or at least the one that I'm thinking of now, is starting at 0. Sorry, I think, okay, Twitch is just telling me to manage my channel on my phone. Starting at 0, divide x by I, 0 to I, divide x by I, if result is So then I think if result cast to int equals I, return I. And then there might be some. I'm trying to think if there's anything clever I can do. But let's just start there and see what kind of runtime and efficiency that gets us. So for int I equals 0, I less than x, knowing, well, I suppose really x divided by 2, because it has to be less than that. But I think we'll find a solution long before we get there. So we're going to take x divided by I. So final int result equals x divided by I if result is equal to I. Return I. Okay, so what if we just try that on, say, 4? Oh, and then if we get here, then I guess return -1, but we should always return out before then. Return, oh. You should always check. Always check your brackets and indentation. Arithmetic exception, divide by 0. Okay, so we have to start at 1. So if x is equal to 0, then return 0. And I think that's just an edge case that we have to handle. Anything else should be fine. Okay, well, that's not what I was expecting. So let's take a look at what we're getting here. I result is 4. Oh, so this should be less than or equal to, so that I always do at least half of I. And then let's try it with 8. And this should be 2. Yeah, so that would work for integers. But I don't actually want... Okay, so that's not quite valid, is it? Let me think that through. Because result divided by 2 is 4. Because the result is between 2 and 3. So I think it's maybe not enough to just do integer comparison. Or if I did, I would need to do something a little bit more granular. And I'm trying to think if so the result is between 2 and 3. So I'm trying to think of what I should be able to observe in here that would tell me that I had already found the result. So let me think if there's a better way to do this, because I could do this as a float, and then if, well, but that's not enough either, because 8 divided by 2 is always going to be 2. So I think, and I'm just curious, try exploring all integers. So I don't know if the hints are helpful here or not. Okay, so I think what I should notice here is that 3 divided by 2, or 8 divided by 3 is less than 3. And I'm wondering if that holds true for 2 as well. So let me take a look at 2. Man, something about that is not happy. Result is -1, so I broke something in here. Slice that. I think this might just be messing me up, because I know I'm going to find something, but the result, just depending on whether or not it's even or positive, or even or negative, that might put me in a bad spot. And what broke here? Or no, 4. 4 is what I wanted to look at. Yeah, so I think what I need to check is if result is less, if result is less than I, then I need to use result -1. I wonder if that's valid. So let's try that. So instead of if result equal to I, because not every number will have an integer as its square root, let's do if result is less than or equal to I, then we're going to return, well, no. I don't know if I need to handle that edge case or not, but if result is equal to I, return I, else if result is less than I, return I -1. Okay, so that works for 2 or 4. Does it work for 8? Oh, I have attempted to run my code too soon. Okay, so that does work for 8. Let's try whatever test cases they throw at me. Okay, and then let's submit it. This feels very brute forcey, and just based on the amount of time that's been spinning, yeah, output time limit exceeded. So we need something a little bit more clever than just, well, and let's try deleting that as well, although this number might be too large anyways. Let's just try that. I wonder if I take out my print statement, if that will help. Faster than, okay. Okay, so that is valid. But let's think if there's anything we can do that would optimize this. So I'm trying to think if there's anything about result that would tell me that I could jump ahead by more than 1. So let's take like a large number. Let's maybe take 100 and just look at, put my print statement back in and just look at what we get from doing 100, because that'll have a few iterations. Okay. And here I'm trying to think through if there's anything a little bit more clever, like I said, more clever that we could do for. Sorry, I keep scooting my chair. I'm trying to think if there's anything more clever that we could do than just incrementing by one, because in this situation, if 2 is much smaller than 50, so I know that I could save myself a lot of numbers by jumping much further, but I'm trying to think of how I could decide that I can jump far enough. So even just skipping ahead by 2 might improve that. But I'm wondering, so if result is so the easy thing, or the first thing that I'm thinking of is that if result is bigger than like my number multiplied by 2 or my number multiplied by itself, then I know I can skip ahead to that. And that should get me past, like, the bigger the numbers get, the less improvement that buys me. But I want to try that. So let's say else um, if I times I is less than result, I gets I times I. So if this number squared is less than result, then I'm way too low. And well, I think that would work. Let's just see what that gets me. Okay, so that's significantly fewer iterations, but like at 5, I could jump all the way to 10. And I'm wondering if there's a way for me to know that, because this really only gets me to skip one number. 1, 2, well, 3, 4, so 2 numbers. So I wonder, so if I times I is less than result, could I skip ahead by like result minus I? No, because that would get me well past 10. So I'm trying to think if there's any other heuristic I can use to jump further ahead, but I don't know that there's anything super clever that's going to get me there beyond just trying it. The other thing I could try would be to just double it every time. So instead of taking I times I, just going with 2 or multiplying it by 2. And in this case, that gets me more, but I'm not sure that that buys me more every time. And I'm going to pause my stream for just 1 second. Okay, sorry about that. Oh, and actually that doesn't work. So what's wrong here? Output was... Oh, yeah. Because then if I jump ahead, then this isn't valid anymore. And really, my jumps are too big. And really, if the jump happens immediately before that, then that's not going to work either. So like if the jump happens the iteration before the result, then then I'm not going to catch it. So I feel like there's something more clever that I could do here, but it's not coming to me. So I might look this one up later and see if there's something a little bit more clever that I could do. But I think I'm pretty happy with that. So let's keep going. Okay. And given the roots of two binary trees, P and Q, write a function to check if they are the same root or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So this is I think a pretty straightforward recursive algorithm. So let's go ahead and write this out. Well, I don't know if I want to take the time to do that. I've been doing a lot of trees and a lot of tree and graph type problems. I'm starting to feel really comfortable there, which is why I'm trying to do more array and kind of number theory type stuff. But this one caught my eye and I figured I would dive into it. So is same tree helper and tree node P and Q are fine. Okay, so what are our base cases? If P is equal to null and Q is equal to null, return true. Those are the same. Else if P is equal to null or Q is equal to null, return false, because here one is null but not both. And I think that's it for our base cases. Oh, so then else if p.val is not equal to q.val, then return false. So those are our base cases. And now I think we want to recurse on each node's left tree. So final Boolean left same gets is same tree helper p.left and q.left. Final Boolean right same gets is same tree helper p.right q.right. And then we're going to return left same and right same. Which I suppose I could have a check in here to see if left same is different. So, because if left same is false, there's no point checking that. So actually, maybe an easier way to clean this up would be return, did I turn on insert somehow? Yeah. And so now in Java with lazy evaluation, if this one is false, then it will not bother evaluating that because it's an AND expression. So that should get us out of recursing down the right tree if we don't need to. And then let's wire it all up. So return is same tree helper, P and Q. And I think that should do it. So let's try that. Cannot find symbol. Is same tree. You gotta call the correct method name for it to find it. Okay. So first test case worked. Let's go ahead and do a few more. Okay, next handful works. Let's go ahead and submit it. We'll see what we get. Nice. Okay. Memory is a little high, but I'm always curious what somebody is doing to reduce their Java memory footprint that dramatically. But we're plenty fast enough, and I think it's probably this because that lets us quit out if we find anything bad about the left tree. Um, if we had some prior knowledge that right or the right trees might not be the same, or something down the right leg or might be different. I don't know how we would get that, but if we did have it, then we could reverse these two and use lazy evaluation the other way. But I think it's fine the way it is. So tree problem done. We are cooking along here. I'm just checking how long. Okay, yeah, so I'm going to stream for a little while longer. So this one is convert a sorted array to a binary search tree. So given an integer array nums where elements are sorted in ascending order, convert it to a height balanced binary search tree. Height balanced tree is a tree in which the depth of the two subtrees of every node differs by never differs by more than 1. So 0, -3, 10, 9, 5. So so my first thought is to start in the middle of the array and then expand outwards in both directions. So if you've got an array, let's just look at an example I'm kind of laughing because I think this is a little bit cheating. So if I have an array and I start here, then that's going to be the middle point of the array if I insert it. 2 is going to be less, it's going to go left. 4 is bigger, it goes right. 1 is going to be smaller, it's going to go left. And 5 is going to be bigger, it's going to go right. But because I'm starting in the middle, each tree, the depth of the tree is going to be the size of the array divided by 2, because I've just got those 2 legs. So it's kind of defeating the point of having the binary search tree, because it's technically balanced, but it's really not great. So other options would be to do something a little bit more clever, like have multiple points where, um, so I could have 2 pivots, let's say. So instead of starting in the middle, I could start at middle divided by 2 and size divided by 2. Or, I said that wrong, but size minus size divided by 2. And I'm saying this horribly, but I could start uh, a fourth of the way in on both sides and then start at 1/4 and 3/4 and work my ways outwards. The downside is I think that might have actually a somewhat similar effect where you would still only be so height balanced. Um, and I think what I'm actually wondering about is because I'm wondering if there needs to be some element of randomness to this, but I don't think so, because then you couldn't guarantee the height balancing. Because if it's, if you had a large enough tree or large enough array and you're doing random insertions, just grabbing random numbers, then you're probably going to wind up pretty balanced. But I don't think that's really valid, because if it's with a really small sample size, the odds of hitting these in the wrong order, like picking 3 and then 10 and then 9 and 5, are, I think, pretty high. Or even, Yeah. So I'm kind of going back to like if we really need to be able to guarantee this, because again, the odds of picking 10 are somewhat high, and then your right node is going to be quite a bit longer. So if we really need to guarantee that it never changes by more than one, I think we do have to do a practical pivot, or some kind of pivoting approach. So let's try that, and I think we'll start with just one pivot right in the middle, and just see what that gives us. And I'll try and keep in mind that we may want to have more than one pivot at some point, but that's going to get involved because we don't want to duplicate insert. So we would almost need to, yeah, that's going to get pretty challenging. Even two pivots is going to be tricky. So, in lieu of a better idea, let's do one, and we'll just start with there. Or start with that. So int pivot, or left equals nums divided by 2. Int, or yeah, I think that should be fine. I'm just trying to think of what happens if I have a very small array, like 0 or 1 elements, which I guess I should look at. Okay, so I'll always have at least one. So we just need to keep in mind that we need to be able to handle a single element. So int right equals nums divided by 2. And then just for clarity, we'll add parens to make clear order of operations. And then I need a way to loop. So a way to know that I've iterated over all of the numbers. And I could just use a for loop. There are a few different ways that I could tackle that, but I think we'll just do I think we'll do, yeah, I'm debating different ways to do this, because you could do this with like a Boolean quit out mechanism, or you could do it with a for loop and just ignore I as it was iterating. But I think what I'm going to do is a left continue at just a Boolean, Boolean right continue equals true, while left continue or right continue. So now left is iterating towards the left. So while, or so I guess really if left is greater than, let's do 0 is greater or is less than or equal to left. And am I past? Do I have a binary tree? Do I need to implement this on my own? Stick like a height balanced binary tree. Definition for a binary tree node is int val left right. Convert it. So I think I need to. It feels like I need to implement a binary tree insertion as well, which isn't bad, but if the problem is focused on making it height balanced, I was kind of hoping they would just do that for me. But apparently not. So it kind of, unless I'm missing something about the intro here, it looks like we need to implement this on our own. All right. So then I guess final tree node root equals new tree node. And here we want nums divided by 2. I think, or nums at nums divided by 2. And I think that should hold. So now actually I know that I've inserted that number, so now I need to edge one up and one down. Okay, so let's real quick implement binary tree insertion. So void insert final tree node root. So now, so what are my base cases? Yeah, I just said that I've done too many tree graph typed problems, and I needed to move on to arrays. And now that I have to flip my brain from looking at arrays to looking at graphs, I'm really struggling. So let me pause and think this through. So what are my base cases? Um, my my base cases are that I have found so if root or so if or no so I need root and then final int val. Let's call it insert val just so it's clear. Insert val. If insert val is less than root.val, and if insert val is less than root.val, if root.left is equal to null, then root.left gets new tree node, insert val. Else, insert root.left and insert val. So then if it's greater, then if root.right is equal to null, then root.right gets new tree node, insert val. Else, we're going to recurse. Okay. So I think that should do the trick. And since we don't need to, we're not really returning anything, that should be fine. So we'll see. We'll see what that does to us. That could get interesting. Okay, so while left and right continue, if so really let me start with my quit expression. So if left is less than 0, then left continue gets false. Else, so now if right is or if left is greater than or equal to 0, we're going to insert root with nums at left, and then we're going to go left minus minus. And then if, pretty much the same thing for right, but if right is greater than nums greater than or equal to nums.length, then right continue is going to be false. Otherwise, we want to do an insert on root nums at right plus plus. And then finally, we want to return root. So this is kind of a naive solution because it's going to lead to a technically balanced but suboptimal binary tree. And I think it's before I start talking about ways to improve this, let's make sure it works. So bad operand types for binary. Oh, so I can't divide an array by an integer, but you can divide an array's length by an integer. Okay, that should fix that. Or right, continue. Man, apparently my C's did not want to capitalize. Was everything else okay? Yeah. Compile error, missing a return statement. So this needs to be outside of the while. There we go. Okay, so it works on the first test case. Let's try the next one. Okay, works on the test cases. Let's try here. And oh, wrong answer. Hey. Oh, okay. So what went wrong? So 3 is right. And then 2 is left. Is this an even numbered array? 1, 2, 3, 4, 5, 6. Oh, okay. So by okay, in which the depth of the 2 subtrees of every node never differs by more than 1. So in this case, so I was wrong. This is not valid because they want to make sure that so they're saying that it's not just the top tree or the root that has to be balanced, it's everything underneath. So then that does make this more interesting. And I'm trying to think of the right way to approach this. Because you could start at you could have multiple quote pivots and have each one, you could have each one go, or no, so 3 and then 1 and 5, and then 0 and 2 and 4. Do they show this kind of thing? Yeah. So for this case, I think we could fix it by having, so we could have for this specific case, we could fix it by inserting, starting at the middle, and then doing okay. So, and the part that I'm stuck on is adding multiple pivots. I don't think really fixes this, but I'm wondering if a divide and conquer does. Because I think really what I always want is to insert the middle element next to keep it balanced. So here I want to insert 3, or 1 to the right of the middle. So here I want to insert 3 with just an array of 2. I want to insert 5 and then 4. With an array of 3, I want to insert 1. So I think this is a divide and conquer where it's not enough to insert one node at a time. I need to, so this this is all gobbledygook. Let's get rid of this. Thankfully, well, not quite all of it, because I still need to instantiate root. And then I think this actually lends itself pretty well to a recursive solution, where I'm always just iterating. I'm receiving the full array, and then a left and a right, and I'm inserting the middle element from the two. So, and then every time you insert the middle element, you subdivide, and if you have any left on the right, you pass that in, and if you have any on the left, you pass that in. So let's take a shot at that. And I think this can be void because we're going to call this insert node, and then just insert final tree node root. And then we're going to need a final int nums. And then we're going to need a final int left and a final int right. So let's think through our base cases. The most obvious one is if left is equal to right, then we need to insert nums at left, insert node, root nums at left, and then we're done. So then we're going to return. If that's not the case, so if left is not equal to right, then we need to take right, well, so then if that's not the case, then I need to find the middle. So final int middle is going to be equal to right minus left. So I need the difference between them divided by 2 plus left. So for example, if I have 0, 1, 2 and 3, 4, 5, I need to take 5 minus 2, which is 3, divided by 2, which is 1, plus 0, 1, 2, which gives me 3. So then well, does that work? I got going fast, thinking I knew what I was talking about. So left is equal to 0, 1, 2. Right is equal to 0, 1, 2, 3, 4, 5. So then here we have 5 minus 2 divided by 2 plus 2, which gives us what exactly? I'm slow, so I'm actually going to do the math out. Divided by 2 plus 2. Because this is integer division, that gives us 1 plus 2, which equals 3. So 0, 1, 2, 3, which is as close to the middle as you can get. So I think that's valid. I think that should be fine. Okay, so this is the middle. And we're going to insert node root nums at middle. And then now we need to recurse. So I need to do insert root nums, and then I'm actually going to wind up recursing twice. So left, I need to do the left half of the array to middle minus 1. And then I need to insert root nums middle plus 1 to right. And I think that should do it. So let's insert root nums 0 nums.length -1. And here, see, now I don't like that I did this. Is there a way to set the value? Because now either I have to prime the pump with the recursion and subdivide, or modify this to have some way of inserting, which I don't really like doing that in the recursion. So I guess I just have to find my middle here, or really final int middle. That shouldn't, I mean, it's really not too bad. It's just this. Okay, and then, okay, and then nums at 0 to middle -1. Insert root nums at middle +1 to nums.length -1. And then we're going to return root. Let's try that. Compile error. Insert. Okay, I think I changed my recursive definition and I forgot to update the call. I should say the definition of my recursive function. That is really thinking about it. Time limit exceeded, so something's not right here. Okay. So system.out.println, or no, I don't want it here. I would rather have it up here. Yes, so println left plus right. And we'll see if that tells us what we want to know. Okay, so so 0 and 2, so 0, 1, 2. So what's, so nums.length would be 1, 2, 3, 4, 5, 6 would be 3. So 0, 1, 2, 3 is our first insert, which I think is fine. So then 0 to 2 is correct. And then we get stuck on 4 and 3. So something's off about, so 4 and 5 looks fine. But why? Okay, so 4 and 5 is fine. Let me Let me just see if we're actually getting the values inserted that I would expect. I think that'll be a good clue. I'm wondering if this base case isn't robust enough, or if there's a chance when the two might skip past each other. So we're inserting 1, which is fine. 0 and 0. Wow. That's not good. Okay. So I've only got a few minutes left. We'll see if we can make any progress here. So what's happening? So 0 and 2 is good. We insert 1. And then after that, we've got we insert, we're at 0 and 0. Why does that insert node twice? Okay, so that makes sense. And then inserting and exiting. And for some reason, I see inserting 0 twice. So left and right are equal. Insert node root. Oh, okay, so this is actually the recursion. So let me just add, okay, I may not, excuse me, I may not have exactly the problem that I thought I did, because I should see it twice, because after the first one, we need to recurse. Yeah, so cur node is 3, and then 1, and then we insert it. So that does make sense. So that fits. So left and right are 0. We're inserting and exiting. So here we've handled inserting 1, which makes sense. And then left and right are 0, and we handle that. And then we've got 2, inserting and exiting, and we've got 2. Left is 4, right is 5, and that makes perfect sense. So inserting the middle, which is 4. Current node is 3, inserting 4, and then left is 4 and right is 3. So the problem is in here. So why does that happen? So left is 4, right is 5. Okay, so what would inserting the middle? Let me add this. So it's got to be a problem with this line. So I'm keeping my left, and middle is less. So I think I might just be able to add another base case for my pointers have crossed, and then I know that I'm invalid. So let me just try that. So if left is equal to right, if right is less than left, we're just going to return. Okay, let's see what that does. There might be a more elegant solution to that, but I think that should work. So let's try our other test cases. Okay, so those work. So now let's start the arduous process of commenting out print lines everywhere they are. Should be one more down here, system.out.println. Looks like they're all commented out, so let's submit and see if that works or if we have more problems. Okay, and I'm guessing I'm taking a hit because of maybe the extra recursion, or there might be a more elegant way to handle some of this to make sure that you're not repeating numbers, but I'm satisfied with that. So with that, we're at a little over an hour. I think I'm going to call that good. And I appreciate anybody stop by hanging out. Would appreciate a follow or whatever else it is you can do on Twitch.